Good morning, students.
Good morning, ma'am.
Good morning, ma'am.
So let us begin the class today with the next concept, that is linked list. In the last video session, I had told you all about queue. We had done with queue, circular queue, and we also saw what is a double-ended queue. In that module, we are left with priority queue. I'm not going to tell about priority queue right now because priority queue implementation is generally done using linked list. Okay, so unless until we get into the linked list, I'll not be able to tell you what is a priority queue. So let us start with the linked list, and then when we go ahead, let us also learn how priority queue can be implemented. So barring priority queue, we have done with the completely with the second module. Okay, recursion as well as the queue operations. Now, today's session, let us see what is a linked list. Now, before I go into the linked list, let us see what are the limitations of an array. What are the limitations of an array? Why do you need a linked list? Why do you require a linked list? Now, when we talk about the limitations of array, first limitation is array is a static data structure. Okay, that means you are going to allocate the memory during the compile time. Suppose I set the size of the array as 10. I can neither increase the size nor I can decrease the size. That is why you call it as a static data structure. Once the memory is allocated at the compile time, it cannot be changed during the runtime. So we don't call it as a dynamic data structure. We call it as a static data structure. That is one of the biggest limitation of array. The second limitation is, as we all of us know, array is a homogeneous data structure. That means elements belonging to different data types cannot be stored in an array. Okay, because array data structure can hold elements belonging to the same data type. Okay, that is next limitation of we cannot have a heterogeneous data structure. Array is not a heterogeneous data structure. Next, limitation is insertion and deletion is not very easy when you talk of arrays. Suppose I want to insert some element in between. Then I have to remove all the elements which are there after that, insert this element, again put in all the elements. Suppose I have an array like this. Suppose I want to delete 4. It is not easy for me to delete 4. I'll have to remove 5, then delete 4, then put 5 again because I don't want to remove 5 also. So insertion as well as deletion is not very easy when we talk of arrays. Then always when we say array has a range. That means it is going to range from, let us say, whatever, from 0 to size minus 1. You are going to declare the size of the array at the compile time. So that much of memory is already allocated for that array. Alright, right? And if you are trying to access something beyond it, now this is 0, this is 1, this is 2, this is 3. Can I access 4? You cannot access. Now suppose that is what you call it as. You are trying to access what is called out of range of the cell. When you try to access out of range, what will happen? It is going to show you some kind of garbage value. It is going to show you some kind of errors. It is not possible. If we that is one more limitation. Next, it can result in wastage of memory. Why wastage of memory? It can result in wastage of memory. Suppose generally let us say somewhere we are declaring array of 50. How many elements we hardly use? Let's say 5 elements, 10 elements maximum. We don't go beyond that. But the other 50, 40 locations, whatever is assigned, memory locations, is all going to get wasted. So wastage of memory is always there when you talk of arrays. And if you do not, that means if you do not, why is it leading to wastage of memory? because you do not know how much space you require in advance. You do not know how much of memory is required. So you are simply declaring A of 50, but you take only 5 or 10 elements, then it is going to lead us to wastage of memory. Okay, so these are some of the limitations of array. So let me again tell you, let me summarize what are we said. We said array is a static data structure. That means the allocation of memory happens during the compile time and not during the execution time. So that means once this memory is allocated for array, you cannot increase it nor you can decrease the memory. That is the limitation. The second one, that's what I said, memory is allocated during the compile time. Then, what is the next limitation I said? We said it is a homogeneous data structure. That means all the elements of a particular, all the elements that are stored in the array are of the same type. You cannot have elements of different data types. That is again a limitation inside the array. Then I said insertion and deletion is very difficult when you talk of array. That is another limitation. Another limitation I said, if you try to access out of range of the values, that is going to result again in some kind of garbage. Then that is again a limitation. Then what I said, it results in wastage of memory. If you do not know the amount of space required for an array, it will result in wastage of memory. So as I said, if you are going to declare 50 spaces and then you are using only 5 or 10, then it is going to result in wastage of memory. Okay, so these are some of the limitations of an array. Now, what is okay? Then why do we require a linked list? What is the need? Is it going to overcome the limitations of an array? Yes, it is going to overcome. If the memory is, as I said, if the memory is allocated during the compile time, okay, then it is fixed and you cannot change it. But that's what I said. If you are going to declare an array of 100, okay, then 100 elements and allocated memory is fixed. You cannot decrease or increase the size of the array. So we are trying to adopt to an alternative strategy to allocate memory only when it is required. So only when it is required, I will allocate memory. I will not allocate in the beginning itself. Then this kind of a special kind of data structure is required for it, which provides a more flexible storage, a more flexible way of storing the elements, which is what is nothing but your linked list. So this does not require, it does not require the use of arrays. It doesn't require the memory to be allocated in the beginning itself. There is a lot of flexibility when you talk about linked list. Now, next, before we go into the details of linked list, let us see what is memory allocation. So, all of us know that in any programming, memory allocation is very, very important. We all know that, correct? Now, that means for storing the values, you are going to assign some kind of memory to the variables, right? They can be done either before the execution or you can also do the allocation after the execution or not after, during the execution. So there are two types of memory allocation. One is called as the static memory allocation. The other one is called as the dynamic memory allocation. Now, what is static and what is dynamic? What is static memory allocation? In case of static memory allocation, what is the difference between these two? Static memory allocation and dynamic memory allocation. In static, variables will get allocated permanently. That means you are allocating memory to the variables. It is done before at the compile time itself. So here, permanently it will get allocated. Here what will happen? You are allocating memory only when it is needed. That is, you are going to do it only when the program unit gets active. We say that. Okay. So the only when it is required, you are going to allocate the memory. The second difference, big difference is what? Allocation is done before the program execution. It is done before the program. That means you are doing it at the compile time. Whenever we talk about static memory location, we are doing the allocation before the program execution. Here, when does the allocation happen? Allocation is done during the program execution. When I say during the program execution, it is done at runtime. Okay. In case of static memory allocation, the memory is allocated before the execution of the program, or it is done at the compile time. In dynamic memory allocation, it is done during the program execution. That means it is done during the runtime. Static memory allocation uses a data structure called as stack. Dynamic memory allocation uses a data structure called as heap. Right? Then that means how do you implement it? Static memory allocation is implemented how? It is implemented using stack. How do you implement dynamic memory allocation? It is implemented using heap. Static memory allocation is less efficient, whereas dynamic allocation is more efficient. Right? Then one another important difference between memory, static and dynamic is there is no memory reusability. That means you cannot reuse the memory again and again. Here, there is lot of reusability is possible. That means when it is not required, when memory is not, when variable is not required, you are going to free that memory. So that free memory is freed. If memory is free, you can reuse that memory. Whereas that is not possible in case of static memory. Okay. Now let me summarize what I did again. I said we started about memory allocation. So as we all know that memory allocation is something which is very important. Any programming language or any programming that you do, you require some storage, correct? So memory is allocated to some variables in order to store some values. Either the memory can be allocated before the execution starts, or you can allocate during the execution. So based on that, there are two different types of memory allocation. One is called as static memory allocation. The other one is called as dynamic memory allocation. Let us see the differences. First, I said in static memory allocation, variables are allocated memory permanently. Okay. But in case of dynamic memory allocation, variables are allocated memory only when that variable is going to be used. If you are not using that variable, you don't have to allocate the memory. Then, when is the memory allocated? In case of static memory allocation, the memory is allocated before the program execution. That means you are trying to allocate the memory at the compile time. Whereas in case of dynamic memory allocation, you are trying to allocate the memory during the program execution. That means you are doing it at the runtime. Then, how do you implement the static memory allocation? Static memory allocation is implemented using stack, using a data structure called as stack. Whereas dynamic memory allocation, you are implementing it using a data structure called heap. Static memory allocation is it is less efficient, whereas it is more efficient in case of dynamic memory allocation. Then one important difference again is there is no memory reusability. As I said, array is a static memory allocation. It is. As I told you already, if you are going to declare an array of 100, size 100, that means 100 memory allocations are already allocated to that array. But are we going to use 100? No. We may use 5, we may use around 10 spaces maximum. The rest cannot be reused or cannot be used by anybody else, any other program unit or any other variable. You cannot, that much 90 memory spaces, let us say, will go waste. That is why we say there is no memory reusability. Whereas in case of excuse me, whereas in case of dynamic memory allocation, reusability is there. That means you can free the memory. When if a particular variable you are going to use a variable, you allocate memory to that, use that variable. Once the usage of that variable is over, you are going to free that particular memory. Free that memory. So these are the differences and types of memory allocation, that is static memory allocation and dynamic memory allocation. Now let us see. We had talked about how memory is allocated, static and dynamic. What are the different types of memory allocation we have seen. Next, let us see what can next let us see what is called memory management functions. How are you going to allocate it? What are the functions that are used? I said you can allocate memory. How are you going to allocate? Now in C programming, right? All of you have learned about malloc and calloc functions, right? All of you have learned about malloc and calloc to allocate memory dynamically. And there is also a function called as free in order to free the memory when it is not used, correct? These functions you have already learned in C. In C++, C++ supports this function also, okay? But there are two more operators. We don't call it as functions. We call it, there are two more operators that are used in C++ for the task of allocating and deleting the memory in a better way or in an efficient way, easier way rather. One operator is called as new. The other operator is called as delete. This operator new is used for allocating the memory, dynamic memory. Okay? And delete is used for freeing the memory. So we are going to make use of these two very much in all our programs. Two operators, new and delete. So new is used for allocating, delete is used for freeing the memory. Now let us see how this new works. What is the syntax and how we can utilize it. Are you able to hear me?
Yes, ma'am.
Good. Now, let us look at new operator. So, new operator, it denotes a request for memory allocation on the heap. Okay. If sufficient memory is available, new operator initializes the memory and returns the address of the newly allocated and initialized memory. For example, what is the syntax? Let me tell you what is the syntax of new. You are going to write, you are going to take any pointer variable, okay? Pointer variable is equal to new and then a data type. This is a syntax for new. Here what is pointer variable is a pointer of the type this data type. Okay. This data type can be any built-in data type including array, including your user-defined data types like structure, class. This also can be used. Let me take a simple example. Int star p is equal to, what am I doing? I am taking a pointer variable. It is initialized to null. Okay. Then I will write p is equal to new int. This is how you are. What are you doing in the second? In this particular line, you are requesting the memory for the variable. That is done using this new operator. I can even combine these two. This whole thing I can even write it as int star p is equal to new int. Both are same. I am trying to combine both these statements into one single statement. So this is how you are trying to. This is how you try to write a a new function or a new operator. You can also initialize some variable. Let's say I can also write it as int star p is equal to new int of 25. That means I'm trying to initialize the memory. We initialize the memory. You can also initialize the memory by using this new operator. Okay. Why only int? Let me take one more example. Float star q. Let us say if I take like this new float of, I can initialize this 75.25 something. Okay. This is how you are trying to do. You can also write. You can also allocate a block of memory, not necessarily for a particular integer. I can write int star p is equal to new int of 10. That means what we are doing here, it allocates memory for 10 integers continuously of the type int. That means you are trying to actually create a size specifies the number of, here 10 specifies the number of elements in an array, right? So you are actually creating an array with 10 allocations. So this will be p of 0, p of 1, like that. All right. So this is the new operator. Similarly, I can use the operator, I said, of freeing the memory. It is a responsibility of every programmer to deallocate dynamically allocated memory. Okay, in order to deallocate the dynamically allocated memory, C++ provides us with a delete operator. Okay, so what is the syntax? Delete. Syntax is very simple. Delete pointer variable. That's all. This is the syntax. So if whatever, let's say, let's take the same, if I take the same example, I can simply say delete p. I can simply say delete q. So that means whatever memories are, it's same as your free. Okay, free you have seen already in C. So say here generally in C++ we make use of new and delete. So delete q means whatever memory was allocated for q. If you don't require q anymore in your program, you have to deallocate that memory. If you are trying to delete array, we also declared array, then you have to write it as delete and then array this one, and then that will release the memory and release the entire array which is pointed by p. Okay. So this is how we try to do. Next session, this is an introduction for our linked list. Next session, video session, I am going to start with what is linked list, how we represent linked list, and what are the operations that can be performed on linked list. I will take one operation in one session. Okay, I will go very slow so that linked list is very, very important for you all, and that's something that you should learn properly. Okay, so let me stop this session at this point. I'll continue and see you all in the next session. Thank you.
Thank you, ma'am.
Thank you, ma'am.
PM mode to speech ಇದೆ ma'am.